or more or less, you've seen how the programs are written. Hopefully, you've started your program. And in Java, you cannot, yes.
I was going to ask on the quizzes, is there going to be a way to like go back and look at them later on, like review the questions?
Yeah, like I said, there's a trade-off there. If I publish them, and that's a default, by the way. I didn't change any defaults. By default, you don't see them. Okay, so when I discuss the answers, feel free to take notes. But I just don't want electronic copies floating around, because writing a quiz takes time, and I'd love to reuse them. Okay, so it reduces my work. It adds some work to you, but feel free to take notes. We spend a lot of time on that, so feel free to take notes. But, okay. And the answers are there in the slide deck. I mean, the concepts are there. I can ask questions on those concepts in 15 different ways, and that was just one of the ways. So the quiz by itself doesn't matter too much. It's the concepts that matter. Okay. Yes.
Could you physically highlight the answers on the screen just next time so that we can be more accurate?
Okay. In fact, I'll try to see if I can just, I'm total novice with this stuff, but I think I can probably show you the stuff that I wrote, and we'll just go through that so that we don't have this problem that this question didn't even arise. Okay? But I wrote it first in a Word document just because I'm uncomfortable with the whole site, and then I cut and paste. Yeah?
Will we at least be able to see the grade?
I think you can see it immediately. It's in the grade book. And again, I chose the defaults. I was too scared to mess around with them. So that's what happens by default. So there must be a rationale for them. And I can see the answer I'm giving you is that I want to reuse quizzes. I think people want to reuse quizzes, and that's why we don't have all the other options. Okay. Okay. So, so again, we are talking of classes. We can't write a Java program without using the word class. Okay. And if you've written a Java program, you have some idea of what a class is. And in this lecture, we're going to try and look in depth at what really a class is. And as the title says, a class has really two meanings. And these two meanings actually show you how programming languages have evolved. The one meaning is sort of a traditional meaning that was, way back. And then the new meaning is the one that is used when we talk of the language being object-oriented. Okay? So one meaning has to do with object orientation, and the other has to do with something else. Okay? And analogies. I'll start with this analogy. Okay? When I've taught 110, I have to tell people what a program is. I start with the theater analogy. Okay? And I say, okay, in a theater, you might have a performance. So here's your performer. And the performer might be following a script. Can you guys see how this translates into the programming world? What would the script be in the programming world? The program. And the performer would be? The computer, the CPU ultimately. In Java, it might be the interpreter at some point, but the interpreter is also run by the CPU. Okay? So the computer follows a program. Okay? So in script, we can write sentences, like I said earlier today, that we can just write a series of sentences. Or we can, I hinted, and supposing we're writing a play. Okay, let's assume a play, a Shakespearean play, epic. Okay? Then we might divide that into paragraphs into scenes into acts, and then finally the full play. Okay? And do we see such structuring in programs? What might a sentence correspond to in a program? A line of code, system.out.println, scanner.scanline, a line of code. Okay? And okay, before we go to that, there's the Shakespearean play, and then there are tweets. Okay, two contrasting things. In tweets, all rules go, even spelling. Okay? You use a different language, and there's really no such structure. Okay? And similarly in programs, we can write programs to be tweetish or to be Shakespearean. Okay? And what do you think Java tries to do? Shakespearean. It puts all these rules on you. Okay? A sentence might mean a statement of declaration of a variable. And how might you further group that now? What may be the next level of grouping? A method, maybe? Maybe a loop, but method, And methods could be grouped into? And classes could be grouped into? Packages. Okay? So now I talk of local declaration versus global declaration. What might that mean? So local declaration means that you've declared some variable in a method. Global would mean you don't declare things in packages. You put classes in packages, but you can do nothing more with packages. A package is just a collection of classes. It is not a collection of classes plus some variables. A class is a collection of methods plus some variables. And those variables we call global because
They can be used by all methods in the class.
they can be used by all methods in the class. They're not restricted to a method. Okay? So we have packages. And now we just assume that, look, I just assume that if you're doing things right, you're grouping things. What do you get by grouping, by the way? Modularity. So you get to see, in a Shakespearean play, you get to see, this is the tragic scene, this is the funny scene, and you get to see each one has a point, and they're sort of, those paragraphs and those acts go together somehow. Similarly, you get modularity, you get classification. So you get, if I just had a bunch of methods and no classes, then it's less modular, right? Because it's all part of one monolithic thing. Now I've said this is my amplifier, this is my speaker, this is my other modules. So we've divided things into sections. Okay? Now, again, Java is meant for Shakespearean plays. But there are other languages meant for tweets. If you were a quick and dirty program to write, what language might you use? I mean, I've got a name here. Any other language you might think of? But it's a little dirtier than Java. Some people will disagree. But that is quicker. Anything else? Scala? Scala is actually even more, it's even more elegant than Java in some sense. Okay, so Python is, Python is a little bit more interpretive. You don't have to say so much about what you're doing. But something else that begins with Java? JavaScript. Okay. So Perl is another language. And nothing wrong with these languages. Okay. And you have such religious wars in programming languages. And people look at Java and say, look how hard it is to say hello world. Firstly, I've never understood why people say hello world in programs. I mean, that's the most useless program I've ever seen in my life. Sure, if I have, I work in collaborative computing, so if I say hello here and you see hello on your screen, that makes sense. But the program saying hello world, I mean, that's just a silly program. Okay? So you can't write silly programs easily in Java. Okay? But you can't write programs that just have one line in Java. And they use that as a criticism for Java. It is a criticism if you want to do a quick and dirty program, if you want to do tweets. But Java is really meant for writing things like Eclipse, okay? Where you won't want to worry. It's such a complex system that if something goes wrong, you're in trouble. I mean, the check style stuff that I've written, it didn't run with 6.8, and a student came to me and said, look, there's an exception being thrown. And it's thrown by your code. I know that. When I disable it, it goes away. Imagine, having all these pieces that don't work properly in a complex system like Eclipse.
What are your thoughts on Swift 2?
You guys are young, I'm old, I don't even know what Swift 2 is. Okay, but I have no clue. Okay,
They say it's the new Java.
it's the new Java. I have dealt with C#. Okay, and again, I don't want to get into religious wars here. It's and I have built so much software around Java. It better be right for you guys. Okay, I can't tell you how many person hours I spent on Object Editor. I told you about Textile, and there's this whole grader program I wrote. So I hope it's a good language, and I don't want to see other languages because I don't want to repeat my code. But C# is a language that I've seen which I prefer over Java in many ways because it came after Java. Okay, okay. Look at this code. Anybody understand what it's doing? What am I trying to do here? I'm multiplying a bunch of numbers, that's true. Am I? Yeah.
Well, each,
Oh, you're doing factorial.
I'm doing factorial, very good. Without any comments, without anything else, you guys are able to figure that out. Okay? Is that a Java program? Is that a complete Java program?
no.
It's part of a Java program. Now, it's a little easier to see what I'm doing. Okay? When you break things into programs, into methods, you increase modularity. You're saying this piece of code has this name. And often people say, when people are declaring things, I say, okay, what's the name of this variable? And they say, what's in the name? Talking about Shakespeare. But name matters a lot because name tells you what the exact role is of that piece of code. And I'm telling you what the role is. And I didn't just call it factorial. I like using long names, and I put an adjective called looping. What might that adjective be telling you? It seems that there might be another adjective which is not looping and would still compute factorial. Recursive, very good. How many of you have seen recursion in? Some of you have. Okay, good. Those of you who have seen recursion will, have no problems with method calls. Okay? If you haven't seen recursion, we'll see some recursion in this class. You'll see a lot of recursion in 410. Okay? So I could also have a recursive factorial. So I'm saying here I'm doing a looping factorial so that you know what to expect. Java program, you have to put the method in a class. And that is what annoys a lot of people. Okay, that why did I have to build all these structures when all I wanted to do was say hello world? Okay? And let's put the pointer on. Now, how many of you have used package declarations before this class in a Java course you took? One person, two people. So you don't have to put this package declaration. Okay? But since we are so sold on modularity, okay, and we are saying, look, we want to, so a package serves what? It serves to collect related classes. So we will insist that you create packages. Okay, now in this first assignment, if you haven't done a package declaration, that's okay, no points taken out. Next assignment, you will be required to create packages. Okay, so every class should be in a named package. And it just makes, you can do imports from named packages. There's a lot of good reasons for doing it. Okay. Now, there's a lot of other adjectives. I put the adjective looping there. And then Java requires me to put other adjectives, static, public. Okay. And let's look at static. What does that adjective static really mean here? And the color purple means that it's a reserved word, it's a keyword. Okay, it's a Java adjective. So what does static mean for those of you who might have done Java before?
It can be used with, or it doesn't require an instance of the class to be used.
It doesn't require an instance of a class to be used. You don't have to know what this word instance means. Okay? You don't need to create an object. You don't have to do object-oriented programming. Okay? So your first program and your second program, you're writing it in a language that calls itself object-oriented, but you're using no object-oriented features in it. Okay? Some of you might have, but you are not required to. Okay? So, so I don't need to instantiate the class, whatever that means. How do I really call looping factorial then from somewhere else? If I'm in this class, I can just say looping factorial. If I'm in another class, how might I call this method? So
You have to call the class.
you call the class, you call the method,
Well,
but you say the method is being called, the target of the method, each method has to have a target that, on what are you calling this method? And you're calling the method on, I heard the answer. The package is just a very passive thing. You don't call methods on packages, so you must be calling the method on factorials, on the class. Static is a very, I don't like the word static. C++ invented this. Smalltalk, which came before C++, used to call it a class method. That means the method is being called on a class. Okay? You always call methods on something. When you don't make it static, you call methods on instances of classes, which we'll see later. When you make it static, you're calling methods on the class itself. Okay? Questions? Permutations. And permutations is using factorial to do the permutation. And it's been a long time since I did permutations, but I think I have the formula right. Let me know if it's wrong. But basically, it involves computing two factorials. I've got a class that does factorial, so I can return a permutation based on that. Okay, so what am I saying? Factorials.looping factorial, factorials.looping factorial, and I'm passing two different arguments. That's the point from programming language point is that. Okay? So that's your class method, or static method. Yeah.
What if the class is in a different package? Then would you have to put the package in front of the class name when calling the method?
That's a good design. Wouldn't it be a good design feature? That if it is in another class, another package, you do that. As it turns out, we'll see that we put all kinds of walls. Okay? And what we'll do is, okay, so I get what you're trying to say. You're saying you have to import things at that point. So we will be importing things, and we will not be, so that's true. Yeah, what you're saying is true. I can always go and say lectures.java.basics.overview.factorials.looping factorial. I can always give that long name. But I never call the method on the package itself. I always call it in a class. The question is, how do I specify the class name? Do I just give the short name, or do I give the long name? Okay, when you're in a folder, you can just give the name of the folder in which you are, or you can give the whole path name from C, user documents, da. So that is what happens when you use a long name. Okay? And indeed, if you're in a different package, you will have to go and either import it, okay, or you'll have to go and give the long. Okay, and we saw importing, I think, in the previous section, so I'm not going to go much more into depth.
So if you import that package, then you wouldn't have to have the name of the package?
Yes, when you import it, you're saying, this is my alias. Okay, there are 4 Johns here. Sorry, there's a John here, there's a John in another class. I go and say, okay, I have, in this context, and this John is this particular person. Okay, so that's what you're saying, that whenever I use factorial, that's the factorial I want to use. Okay, and I do want you guys to make sure that the short name of the class, which is what this permutations is unique across packages. Don't try to have 2 permutations in 2 different packages. That just causes a lot of problems. Okay, so the short name will be fine. Okay, questions? More questions? So static or class method is invoked on a static class. Classes are static. They are created when the program is created. Objects, which we'll talk about later, are dynamic. They get instantiated dynamically. So that is the word static. C is a very implementation-oriented language. C++ was in the same spirit. So they were looking at how things are implemented rather than what they mean conceptually. Okay? So that's what a static method is. Okay, and this is the class, and we're using the short name of the class because permutations happens to be in the same package as factorial. Okay? Okay. Questions? More questions? Computing a factorial is expensive. If you went to recursion, it would be even more expensive. Okay? So what you might want to do is remember a factorial you've computed before. Okay? Let's say 3 factorial is something, or 20 factorial is something you're going to use again and again. You don't want to compute it each time, so you store it in some variable. Okay? So that's what I've got here. I've got another class. The class stores 2 variables, a number and the corresponding factorial. Okay? It has a method to return the number if somebody wants to know what the current number is, currently remembered number is. It's got a way of setting the number. Whenever you set the number, the value that is passed to the method is stored in this global variable called number. Plus the factorial is computed for that number, whether you want it or not, and stored here. And once you set the number, once you set 20, you can say get factorial again and again to get the 20 factorial. You don't have to go and compute it again and again. So that's what this problem is doing. Okay, can you guys see why I used the word adjective spreadsheet here?
Gives you all the data from that single factorial.
It gives you the data from the factorial. It gives you the factorial data, right? So why is it not a database then? So how would you define a spreadsheet? Sorry? Columns and rows, that's how it's displayed. That's a table. It's a table with some computation there, right? It's a way of programming. So are the columns and rows ever related to each other? So when you go and change some independent cells, some dependent cells get computed. That's the power of spreadsheets. I mean, you know, people used to write programs to do so till some MBA said, hey, why write programs? You know, why not just have this visual programming language? And those poor guys who created VisiCalc never made any money. But today we all use Excel and others. Okay? So can you guys see that there's dependent and independent values here? Whenever you change number, the factorial is computed. Just as if I go and put your new score for the quiz, your grade will automatically get computed in my spreadsheet if I wrote it right. Okay? So the factorial, the values are stored here. So this is why I'm calling it a factorial spreadsheet. Okay? We've understood static. Now let's look at this keyword public. You know from declaring variables that you can say public static int final number equals something. So I could have put public here also. I didn't. I put public for get number, set number, get factorial, but I did not put public for these 2 variables. So what does public really mean, and why did I make this choice? Yeah.
When somebody accesses the class to use its methods, it kind of hides things that they don't need access to.
Okay, so the whole idea of public versus non-public is that you're hiding or not hiding. I have my public persona, I have my internal thoughts that I don't want people to know about, and we keep them separate. Okay, with Facebook it becomes a little hard, but people do try to do that. Okay, so that's the role of public and non-public. Public really means it's like a public profile. Okay, everybody. The opposite of public is what? Maybe. Maybe it's protected. Maybe it's default. It's not one of the other. Okay, there's a degree of publicity, you know, degree to which you make things public. Saying public means no restriction. Then you can put different degrees of restriction. Okay, so I am saying get number is as public as I want. I mean, it's just no restriction. Okay. Now, why did I, in this specific problem, why did I not make this? Yes, I hid things. I'm hiding this particular number and factorial from other people. Why do that? Why not make this public also? Yes, you might have learned in your programming 101 that's a bad idea. Let's go and see whether that's really the case or not. In this example, what would go wrong if I made those two things public?
You could change the value independently of updating the other one.
I could change the value of factorial.
Of either of them without updating the other one.
I can change the value of either variable without updating the other variable. We want a constraint that factorial should be factorial of that number. And if I went and exposed that variable directly, that constraint will be violated. Every class has an invariant, a certain constraint that it tries to implement. And that is exactly the right answer. So public versus non-public means, can you just access it from arbitrary places or not? Can anybody look at your Facebook profile or not? Okay. Then we can get into friends and acquaintances and so forth. That's a different issue. Okay. And we can actually change it arbitrarily. Okay, we'll stop at this point and start off next. Which is what somebody said last time. But it's not quite a database, it's a spreadsheet because there's dependencies there. Okay, just in a spreadsheet, you have dependent cells and independent cells. You have dependent variables and independent variables. Okay, so that was, you know, one point I was making here. The other point had to do with public. Okay, and we made these methods public, and we made these variables non-public. Okay, we don't know what non-public exactly means. If we don't type anything, it's non-public. Okay, there's something called private also, where we have to type something. So I'm lazy about typing. I'll just type nothing and just say it's non-public, whatever that means. Okay, what that means for now, when we look at inheritance, we'll see exactly what it means. What it means for now is that there is no arbitrary access in other packages. Okay, so with public, we know there is arbitrary accesses in other packages. Okay, you can build a library and somebody else can import your class and they can use all your public variables. Okay, and in the other case, you have to you don't have this guarantee. The number and factorial variables are visible in some places. We don't quite know what places they are, but they are not visible arbitrarily. Okay, so given that, you know, we wanted to know why did we make these methods public and these variables non-public? Okay, and the answer we got was that, look, there's a dependency between number and factorial, which is honored by these methods. Every time we set the number, we go and calculate the dependency. Okay, whereas there is no dependency between, whereas if you go and make this public, somebody can change the number without changing the factorial, and now the factorial will not hold the factorial of the number. Okay, so certain constraints are violated. Okay, and for that reason, we made them non-public. Okay, so it's like in a car, we allow the driver to go and access certain things that are expected. You can drive, you can steer, you can accelerate, but you're not supposed to open up the engine. Okay, if you open up the engine, you may do something bad and the warranty is off. Okay, so similarly, if you, in Java, you can actually, and I did that in my check style, you can even go and access non-public variables by using something called reflection. And when you use reflection, you say, yes, I'm being bad, let me be bad, I know what I'm doing, and it's my problem if things go bad. Okay, and that's the reason why my check style code works with 6.5, but not with 6.8, because they changed something in the engine which I didn't expect. Okay, so so that's what's happening here. Okay, and that, so now classes just become a way of dividing your program up into portions. It's like taking this whole building, rather than having one big open space where I can hear what's going on in the next lecture and there's no privacy at all, we are putting walls around related methods and variables. So in the case of factorial, there are those two variables, there are those two methods that need to access those variables. That factorial of the spreadsheet is one logical unit. Okay? So we've put a walls around that unit, and we separate it from the wall that computes the factorial, for instance. Okay? This is a factorial spreadsheet, this is a factorial computer. We can have a permutation class. So as we saw last time, so we put walls around and we said, this is visible outside, this is not visible outside. Okay? So classes serve as walls. Okay? That's one role they have. Okay? And the walls make only certain methods and variables visible outside, and ideally, you should make no variables visible outside, and you should make only some methods visible outside, not all methods also. Okay? So we saw in that example that certain methods should be made, the methods should be made public and the others and the variables not. Now, what general principle can I give you? Is it all case by case? It is somewhat case by case, it's application independent, but is there some general principle that you might have seen outside computer science that you could follow in deciding what to make public and what not to make public? Can you give it a name? Something you might have seen. So how many of you in your class, in 101 class, saw this rule that do not make variables public? You did. Okay. And any reason given there, any principle given there that you remember? No? In military, can you think of some principle people follow in deciding what is top secret, what's secret?
Well, like, let's say in the you're interesting trees, if you're writing a big program, it will allow for data breach. It's easier to hack something private.
Sorry, a little louder. So you're writing a big program.
Yeah, and if you have something that isn't encapsulated, you have personal data that's stored in a variable that's public, it's very easy to access that variable because it's not encapsulated in any different class component.
Okay, so you're saying that if we make everything private, then it's not encapsulated. That's the word. So encapsulation is something we talk about. It's the principle of encapsulation, that you encapsulate variables so that they're accessible through methods. Okay. So can you think of a broader principle? Why even follow encapsulation? And why do we, so why don't you let your private thoughts, all of them, be in Facebook?
You want to make it simple to the user?
Yeah. You want to make it simple to the user, so why bore them with information? Yeah.
Or there's certain information that you're willing to share, but then there's other ones that you want to keep to yourself. Like, you can share the more important and broad information, and then if you were able to put all your variables public and make it, somebody could completely take all your information, and maybe that would be.
Okay, so the danger is that if you shared all the information, somebody could do bad things with it. But you do want to share some information. So the information you will share is the information. How will you decide which information to share?
The information that can't arbitrarily be changed.
The information that cannot be arbitrarily changed or would violate the constraints. Okay, that's one way to look at it. And in the Facebook case, what do I post in Piazza? I don't post everything that's going on in my head, right? I go and post the things that you need to know. I may make a decision, I may make a mistake in deciding what you need to know, but that is the need to know principle. You guys heard of need to know principle in ordinary English? This is the need to know principle. It's also called the principle of least privilege. You do not want to give any entity more information, more rights than it needs. Okay? So principle about what should be visible outside, we know what can go wrong, and there are these fine details you have to think about that, hey, things got constrained. It's called the least privilege principle, where you give the least privilege to some user as is possible, so that they can do the task, no more. Okay? And need to know whatever they need to know, and so the general will not tell the soldier everything that he knows. Okay? Because the soldier may not need to know it. Okay? But the soldier typically is required to tell the general all he knows, because the general is supposed to know everything. Okay? So that's how you have this hierarchical thing, and a lot of computer science concepts go on the hierarchical privilege basis. So do not make non-final variable public. So basically, that translates into, in computer science, not making non-final variables public. Okay, so the final variable, that's like an oxymoron, right? A variable is a value that can change. Variable is a location in memory that can change its value. Final means it cannot change its value, so it's not really a variable, it's a constant. Okay, but it's declared the same way as a variable, so we call it a final variable. Okay, so just follow this principle, and in some cases, that may not be so bad. Okay, and that may not be so bad because it may not be the case that there's number and factorial and there's a dependency between them. There may be number one, there may be number two, and they may have no relationship between them. There may be the quiz score, the recitation score, and there may be no relationship between them. But there may be. I may have a little method that says, if your exam score is really high and your quiz score is really low, I'll give you a few extra points on the. So you never know. It's often short-sightedness that makes you think that, there's no relationship, I'll make them public. Okay? After all, Java does allow you to make public variables. So it does think that there are cases when variables should be public. Okay? But for this class and in general, I would say don't make any variable public. You can always, so if you don't make the variable public and you want that information outside the class, you want to basically, so do not give the user of some code more rights than it needs. You have to basically define methods. Okay? So, and anybody heard this term property before in terms of programming language and objects? Okay, so this really means that you go and don't export variables, export properties, and let's just let that be a little suspense right now what it really means. We'll see a little later what it really means. Okay. Questions? Motivated property means, let's go and classify the various methods here. Okay, so this is a method, this is a method, and this is a method. Right? Now, can I distinguish get number and get factorial somehow from set number? They're both, all three methods. Can I just say that these two are somehow different from this? And there are many ways you can say that. Get returns something, and set doesn't return something. And a method that returns something is called a function. And a method that doesn't return something is called a procedure. Okay? So I can call this a function, procedure, function. Can I somehow further classify these functions and procedures? Can I say that this is this kind of function and this is this kind of procedure?
The procedure it mutates the values.
Okay. So which procedure mutates values?
One is a procedure.
Sorry?
Set number.
Set number is a mutator, and get number is a, what's the opposite of mutator? Where did you hear the term mutator? Or did you just invent mutate?
I did not invent it. I heard it on a Udacity course.
Okay, okay. And you must have heard with mutator another term. Accessor. Okay. And what is an accessor? Get number, get factorial. Anybody heard some other names for these two kinds of methods? Getters and setters. Okay. How would you define a getter? Can I formally define a getter? I mean, you can, when you see it, you know it's a getter, but if I was to say procedure named X is a getter if it retrieves a value of, so any method that returns that, so it takes how many arguments? None. It is a function, and it returns the value of a variable. And then setter would be what? Sorry, a little louder. Okay, so a setter is a method that takes as an argument. How many arguments does it take? Well, what's it going to do? It's going to take the value and you assign it to a variable, right? So if there are two values, what's it going to do? Gets confusing. If its job is to change a variable, it just needs one value. So it takes one argument and it sets some variable to that value. Can it do some more things also? Is this kosher? Is this fair? So it should change the value of a variable and maybe it can do other things. You guys like that definition?
Are methods that take more than one argument not considered mutators then?
Are methods that take multiple arguments not considered mutators? What do you think? I mean, if your whole goal is to change a variable to a particular value, why are we confusing things? You might want to have a separate function that takes two values and computes a third value from it, and that value is passed to the setter. But to confuse things and to do multiple things in one method is not considered a good thing. Okay, so let's make these two things separate. Calculate the value to be set and set the value. Okay?
What if there was something that naturally had more than one value, like latitude and longitude or something, and you just had two every time that you would set?
Okay, so that's an interesting thing. What if I had latitude and longitude, or the Cartesian x and y things? How should I ideally model that?
You just say like set number and latitude, and longitude.
Okay, so you would have two different variables, longitude and latitude. Anybody think of a better way to do that? You could use an array, one element for longitude and one for latitude.
It would be overkill for longitude and latitude, but there are times when we would need to set something that might have tons of variables at once.
Okay, so anybody who's done object-oriented programming, yeah?
You could make a coordinate class that has both of them.
You could make a coordinate class that has those two things, and you would declare that variable to be of that coordinate class type. So it will become a setter of that thing. Okay? So what I'm talking about is a very technical definition, by the way. Okay, it's conceptually a setter. You've broken it into two different things, but here we're going to consider that to be one logical entity. Okay, what you've decided is that there's one logical entity that you've broken up into two physical variables. That's not a good idea. Again, you're doing multiple things in one place. Let's go and first create a coordinate class, then we'll go and figure out how to go and set it. Okay? Okay. Okay, so you're happy with this definition that setter takes one argument, sets the value of a variable, getter returns the value of a variable. Okay, let's confuse things. What if okay, and now I can define a property. Assuming though that's a definition of a setter, I can define a property. I can say this class has a property called number of type int. Not a variable called number of type int, but a property called number of type int. You set the property by calling set number, and you return the value of the property by calling get number. A variable you would go and access directly, whereas a property you would go and access and set through methods. Okay? So that's what I meant when I said, don't export variables directly, define properties, and when you define a property, you basically define getters and setters. Okay? Now, I said its name is number of type int. How did I pick this name number for the name of the property? That's what you're getting in setting, by which you mean that my getter name is of the form get number. And if I'm going to call this get number, I better call this set number. That's how they are logically grouped together. That's why they together define a property called number of type int. Okay? And is there any constraint on the types of get number and set number? Types declared in the signatures? How did I know it's of type int? The variable is of type int. Good, good. That's one way to look at it. Another way to look at it, if there was no variable just from the method headers, supposing you are a user of the class, all you can look at are the public methods. From those public methods, can you go and derive what the property type is? You can't even look at these inside variables.
Because it says int on get numbers and set number asks you for an integer.
Okay. So get number returns an int, set number sets an int. So by purely looking at these are called the headers or signatures. The header of the methods, I can figure out what the properties are. Okay, so number of type int and factorial of type int. Purely from, so the whole point of properties is that there's an external view, your public profile, and there's a real code. To derive the properties, you just look at the method headers. You have no idea what's going on in the class. The public methods are all you can look at, and from that you go and derive these properties. Okay? If these properties can be derived by purely looking at the method headers, does it really matter that there was a number and factorial variable in the class? To the user, no. So my getter and setter should not be defined as something accessing a variable or setting a variable. It should be just defined as a getter is a method that starts with the word get, and, well, let's put it another way. Each class defines properties of some type. So if you have a property P of type T in a class, then you better have a getter whose signature, whose header is named, has the type int as a return type, and whose name is get P. Okay? So we can basically from the method headers, without even looking at the variables, define properties. Again, how does that become important? Let's look at a class that looks exactly the same from outside. Get number and set number. What happened there? Okay. So I have get number and set number. My set number no longer is changing the factorial variable. In fact, I have no factorial variable. I still have a get factorial. To the user, there's no difference. They can just look at the public methods and they can go and access the functionality. This doesn't have to happen to be a very efficient one if you set the number once and retrieve it multiple times. Okay? But it is a valid, but if you set a variable, set number and never access the value later, then the previous one is inefficient. So sometimes that is good, sometimes this is good. Some users may want this, some users may want that. And now you see again a reason why we want to not make variables public. Don't give away too much of what you have done if they don't need to know it, because then you can't change your mind about things. If I made those variables public and people depended on that, then I can't change my mind about it. If checkstyle had made those variables public and I didn't have to go and cheat to go and access their values, they couldn't have changed checkstyle to checkstyle 6.8 without destroying other people who were accessing it legally. They created problems for me, but I knew I was in trouble. So that's the whole point. That don't make these variables public because you may change your mind. Forget the fact that there are constraints among the variables. Just the fact that you might change your mind about how you do things without changing the external functionality means don't make variables public. Okay? So I've given you multiple reasons for not making variables public. And I've also in the process defined what a property is and what a getter is and a setter is. And I think the next slide is questions before I go further. Like a variable, it is a named unit of state. Like a variable, it has a type. Okay? And it is defined in some class C. Okay? And we know we have a property named P of type T if we have a static property named P of type T. Just as there are static variables and non-static variables, there are static properties and non-static properties. Okay? So there is a static property named P of type T, and that property, as long as there is a method called getP that returns type T. Okay? No, it doesn't matter what the method is really doing, whether it's really accessing a variable or inventing a value, computing a value. Okay? You might have a getPy in your class, and getPy just returns some constant right there. Okay? It may not even be stored in a variable. Okay? So it doesn't matter whether there's an underlying variable or not. Okay? And if we only have a getter and we don't have a setter, then that property is of type, that property is a read-only property. If I, in addition, have a set P, where and there's a property named and the parameter of that method is T, then it becomes editable, and the return value should be void. Okay, so there are read-only properties, editable property, just as there are final variables, not really a variable, and non-final variables. There is these two kinds of properties. Okay. Questions? So these two P's should be the same, and these two T's should be the same. Okay? This is called a getter method. This is called a setter method. Okay? So this is a precise definition. I might ask you this in the next, well, since we're having a lecture, I won't quiz you on this lecture. Okay? But this is something that I might ask you in various ways. What if I change the name of getP to obtainP? Will that still be a getter? It functions the same, but by my definition, it wouldn't be a getter. So now, when you write English and you use the word get already in a sentence, or maybe in a nearby sentence, you look for alternative names later so that you don't become boring, right? You look, maybe if you don't know another synonym, you look up the thesaurus and say, I'll use obtain now, otherwise it just gets boring. In computer science, we are boring. Okay? We say, we've got a word called get. Use the word get every time in every class. Don't confuse us by using obtain later. Why do you think that's the case? I mean, there's always pros and cons. What are the pros of this? So someone reading that stuff is easier for them to read. Okay? We get our thrills from writing complex algorithms. Writing one loop where somebody else thinks there should be two loops, right? So that is the thrill we get of doing things cleverly. Not by writing, using different names and creating excitement out of that. That's one way to look at it. And this is going to be very important in this course. It's not just, nobody's going to read your program. Maybe the TAs will, okay? But mostly it will be my automatic grading program that will read your program. And it becomes much easier if we restrict the vocabulary to certain words for automation. Okay, and this is not my idea. I mean, Java has a tool called the Java Bean Builder that was based on this premise that let's go and agree on a set of conventions, and then we can build these tools that do good things for the programmers, as long as they follow these boring conventions. Okay? So these conventions, so this is not valid purely as a convention matter, not as a conceptual matter. Okay? And what about this? Should I be able to call this new value, new P rather than new value? Do the names of arguments ever matter, you think? Do they get remembered by the compiler? They never get remembered by the compiler. Okay? A tool that wants to exploit this information doesn't even know that what the name of the parameter was. So this is fine. Okay? So these are bean conventions. They are for humans and tools. Like I said, Java did this bean builder program, and I've written 3 different programs that are going to be used in this class: Object Editor, the real grading program that you guys don't see directly, but you'll see through the server soon, I hope, and Checkstyle. Okay, and they rely on these conventions. Okay, and you'll see. Hopefully, before the end of the class, you'll see actually a program processing another program and using these conventions. Okay, questions? Okay. So any class that has a single getter, one or more getters, or one or more setters is called a bean. And you guys see how the word bean might have come around in the context of Java? Okay, coffee and the bean idea. Okay, so you can see how bean was a sort of fundamental concept in Java. Okay, they invented this sort of thing. We've already seen what read-only and editable properties are. Okay, number is a what kind of property? Editable, because it has a setter, right? And factorial is a dependent and independent. So what's a number? A number is a independent property, and factorial is a. Are all read-only properties dependent properties? No. Get pi is not. Right? So that's a different classification. Stored and computed. Number is stored because a property is stored if its value is reflected in a variable, right? And so number is stored, factorial is not stored, it's computed. Okay? And we saw that a dependent property may be stored or may not be stored. So this is a separate classification. Okay? Questions? Okay. Spreadsheet 2. I did the minimum typing possible. I copied the class, changed the name to 2, and I said, hey, program component 1, use the first spreadsheet. Program component 2, use the second spreadsheet. Once I got the first one correct, I can make this one. Fine? Anybody not fine with this?
You also make a new instance of the class to create an object.
Okay, so you're giving me a solution that I don't understand right now, okay? So tell me the problem you're solving before you tell me the solution, because I'm going to repeat the solution a little later, but I want the problem first.
You have to create a class for every factorial you want to compute.
You have to create a class for every factorial that you may want to compute. And how many factorials might you want to compute? Unlimited. How many classes can you create? Finite. How many times can you do copy and paste? Sure, it's fast. Okay. Any other problem? Supposing I just needed these two guys. That's it. I'm not going to use a third one. Any problem still with the copy and paste picture?
It has to compile two classes, which are pretty much the same, but it still compiles it twice.
So the program has to compile twice, and you're worried about the program, right? Somebody said last time, what does efficiency mean? Human efficiency or computer efficiency? And you're clearly the computer efficiency person. You should go into graphics. They really care about efficiency. How about some human efficiency things?
It's really easy to make a typo and say static looping factorial spreadsheet instead of static looping factorial spreadsheet 2.
Okay, so you're saying my names are not good. And I could, and I should maybe say, okay, whatever program component needs for spreadsheet 1, somehow I should say, hey, program component 1, that's your spreadsheet. Not, okay?
If you later find some strange bug and you have to edit the class, then you have to go in and edit both classes. Or
That is the key. Copying and pasting is easy. It's not a big deal. Trust me, people will say it saves effort. It is so easy to copy and paste. It is so hard to go and think and figure out how not to copy and paste. Okay? The problem becomes when you go and change something. And the thing is, our brains are wired to put energy on creative things and not on mundane things. Once you fix the bug in number 1, your brain says that's a boring task to go and fix the other 2, and it just forgets to do it. Okay? So we can do, so here's what we can do. We can set number 2 in one and set number 4 in the other one. There's code duplication. Okay? There's compiler energy wasted. There's initial work, which I'm saying is nothing. Trust me. I do it all the time. I copy and paste because I have a deadline and I don't want to think. Okay? And of course, I'm going to make sure that you guys don't do that. Okay? But later I do go and fix it. Okay? And maintenance. This is called maintenance. That later you have to maintain 2 pieces of code that are identical. And not only do you find a bug, you might be a very good programmer, but some security hole may be found later. And you have to fix security hole in both of these things. Okay, so Microsoft, comes up with features, then it takes out features later. Now I ask them, why? I like that feature. Where's that gone? So nobody else uses it. And we don't want to go and maintain it, and we don't want to worry about security holes. Okay? So now we need a solution and this new language of instance, whatever that means. Okay? But can you tell us how one goes from what we have here to what you're thinking about?
I don't know.
Somebody, I thought, anybody else want to tell me? Yeah.
Create a constructor method?
Create a constructor. Constructors are part of the solution. Once we come to the solution we want, constructors would help, but they're not necessary.
Create a new object.
Create a new object. I don't know what that means. I know what this class means. Can you tell me how I should change this class somehow?
You should take the static off of all the things that are static.
You go to take all the statics out. All the extra typing you did, you get rid of it. It's easier to do what you guys are talking about in some sense. If I take static out, what does that really mean? Now, English-wise, it means, static means, in this case, when the class is created, as soon as the class is loaded in memory, which is what happens when you go and call some method in the class, all the static variables get allocated some space in memory. Okay, so we get a number variable here and a factorial number variable here, part of the static spreadsheet 1, as another variable part of 2. Okay? Now what we are saying is what? I create a class, there's no static in it. When I load the class, am I doing anything with memory then? No. So when do these variables get allocated space in memory?
You create the object you need.
when you create an object from that class. And that process of creating an object from a class is called doing what to the class? Instantiating the class. Now our variables are not locations in memory, they are templates. We are saying, I've created this class, not to be used now. But when I go and say new class later, at that point, Java interpreter, look at what the class had. For every variable that's not static, create a space in memory, and associate that with this object, with this instance. So I just create one class, and I keep instantiating it rather than copying and pasting classes. This is the key to object-oriented programming. It's called object-based programming. When I look into inheritance, it will become object-oriented programming. But if we don't look at these subtle differences, that is what it means to do object-oriented programming. Okay? So class is not just taking a room and breaking it into wall, taking a big space and building rooms. Those were modules. Classes are modules, plus they're something else. They are templates, they are blueprints. You can think of them as, because they are not by themselves active, they can be acted on, and then you create something real when you instantiate the class. And that is what a programmer does. That's what the program does, and not something that happens before the program, when the program is okay. So classes now become types. All these instances, what are the types? Types are many things, but types basically classify values. All ints have the same operations you can do on them. All doubles have the same operation you can do on them. All our factorial spreadsheets will have the same methods. So they'll be united by that. And that unifying concept is a type now. Okay? So a class is not just a wall, it's a generative thing, it's an active thing, it's a type. Okay? And values of these types are created by instantiating the classes, and they share the behavior defined by the type. Okay, so these values have copies of the dynamic variables defined by the class. So now the dynamic variables, the non-static variables, the instance variables, they are the ones that will hold values, and they'll get created when you instantiate the class. Okay? Questions? Okay. So a class is a template or blueprint for generating instances. It's also a module. That's what gets confusing. In Java, it can be. So far, in assignment 1, you just had one module. Some of you have more modules. Some of you are even instantiating things. Fine, that you know things, you're using them. Good. But as far as I was concerned, if you just define one module with 2 methods, I'm happy. Right? So that's what was required. In the next class, in the next assignment, you'll create multiple modules. And in the third assignment, you'll actually start instantiating things. Okay? I think so. Just as he said, take out the word static from everywhere. And you have now a class. That is a type. And what can I do with it? I can declare a variable to be of this type. That's a type. And I can assign to it not some numbers, number 5 or a string hello, but an instance of this class. And I say new looping factorial spreadsheet that says this is the name of the name of the variable in which I'll hold an instance of this. I can have another variable that holds another instance of it. I guess I did an extra copy and paste here. Yeah? I told you copy and paste is easy. And of course, I'm not even consistent here. Yeah, I know what I wanted to do. I wanted to name this 2, and I just forgot. So anyway, one of these should be a 2. Okay? And the other one should be eliminated. I probably will forget to do this because it's a boring task. Okay? But I'll try to remember. Okay? And I can say factorial 1.set number 2, factorial 2.set number 2, or 4. Okay? Again, I was doing copy and paste. And I can have different factorials. Okay? So if I remember, I will go and change this to 2 and 4, and I will go and make this factorial 1 and then 2. Okay? Questions? So no static. You have instance variables and instance methods now. Okay? A new set of instance variables dynamically created each time a new instance is created. Okay, so what does it mean to instantiate a class? To create a new bunch of instance variables. We are using class as a type, and we are creating a class instance. Okay, so by not declaring this as static, we provide the ability to create an instance. We're not really creating an instance. We're just saying you can be instantiated. Now we are using that ability to do it. Okay? So this thing, whatever is stored in factorial 1 is an instance. And the method that you declared here was an instance method, and that method is being called right now. Where you previously said class.static method, every method has to be called on something. A static method is called on the class. An instance method is called on an instance. Okay? Fine? You'll be doing a lot of this, so this is all going to get, in your genes, in your DNA. And you can think of actually an instance being an extra parameter to a static method. It's saying, do all this stuff to this particular, that's how it evolved. That people, the same kind of programming people did earlier, where they just passed an extra parameter to some static method and it became like an instance method. But we'll just, in object-oriented languages, we think of the special first parameter as being a special parameter that defines the instance, and then the others are parameters to the method itself. Instance of is not just something we'll use in English. You can use that in Java also. So if I go and say new looping spreadsheet, instance of a looping factorial spreadsheet, I'm writing a Boolean expression. And this expression should return true. A new looping factorial spreadsheet instance of factorials, false. It's just string, false. Okay? So you can actually go and do this. You can go and take an object and say, is it instance of this particular class, or this type actually, and it'll return true or false. Okay, so this is not just something to be used in English, this is something to be used in Java. As it turns out, it's not recommended you use instance of very often. In fact, it's not good programming, but at least if you want to understand the concept of instance, you can use this operation. Okay? So true and false are Boolean values. Instance of is a Java keyword. Okay? One word. If class of object O is type T, then instance of T returns true. Simple. That's the rule you were following when you decided what was false and what was true. Okay? So now I have a class with double roles. Class can be a module. If you have static, if you're focusing on static, class can be a type if you're focusing on non-static. Somebody who's programming Java, can you have both static and non-static in one class? No? Yes? Actually, you can. You can, but they can't access each other. You can, but there are some rules about what happens. But you can. Okay? And let's try to understand that, because then suddenly this blueprint idea, sometimes it's a blueprint, sometimes it's a wall. I mean, you need some analogy that combines both the idea of a blueprint and a wall. Okay? And I think I'm old enough that I actually saw the whole craze of object-oriented programming starting, okay, or not really starting, but at least taking off, okay. And when people said, why program with objects? They couldn't quite figure out, and one of the things they said was, oh, computer entities become like physical objects. That's the beauty of object-oriented programming. They hadn't quite figured out all the ways in which it could help. It was just a new field. And the thing was that at that time, C was an ingrained language. Unix was the operating system, C was the language, at least in USA. In Europe, they were more advanced. They went and looked at more modern languages. And people didn't want to give up C. I mean, it's like, who wants to give up English, right? Even though it's got all its flaws, the pronunciation is strange. But we just know that language, and we're just going to have that, speak that. Similarly, with C. So they were trying to find reasons, and the intuitive thing they would come up with is, they're like physical objects. They're like the physical world. The computer world becomes like the physical world. It becomes so easy. That's a level of discussion that used to happen. Okay? So when you talk of objects, physical objects, you can think of natural objects, or you can think of manufactured objects. Based on what you just understood of objects, and some of you have done some programming, if you were to choose between natural objects and physical objects, what do you think would correspond more to computer objects? Sorry? Manufactured objects, somebody? Because you make them? I once asked this, anybody else? They have parts, but I have parts. Flower has parts.
They're made off of blueprints.
They're made of a blueprint. We don't know. Well, we've got a blueprint, right? The DNA. But still, yeah.
You can make an object out of multiple objects.
You can make an object out of multiple objects.
So manufactured objects are made out of natural objects.
Manufactured objects are made out of natural objects. So you're saying it's a false dichotomy, right? But the moment manufacturing happens, we'll call it.
Because they're relatively simple compared to natural objects.
So they're nice, relatively simple compared to natural objects, though we are trying to make more and more complicated objects that will drive themselves. You know, who knows where we'll go. Okay. Anybody else? Sorry.
Based on what the user puts in or starts it with, in some ways they're like natural objects and then they vary and change.
So they are like natural objects that can vary and change. But a car changes, right? You add miles to it. You put bumper stickers on it, right? So you can put accessories, you can put a stereo system. And even with programmed objects, you really can't change them very much. You can change their state. That's like saying, let's go into the accelerate mode versus, just stop mode. Okay, somebody else had their hand on?
And they still have the same functions.
Okay, when you duplicate, when the two cars are absolutely new, no miles added to them, hopefully they are identical. And that's what somebody else once said. They said natural objects, no two humans are alike. Well, maybe you have a double or a triple somewhere across the world. But there is much more uniqueness in natural objects. Okay? But the whole point is they're made from blueprints, they're meant to be uniform, they're meant to be boring that way. Okay? So, if my object is a car, what is a method that I invoke on an object? Brake, accelerate. Okay? What is my class?
Depends on how you want to build it.
So this particular car was made how? Or where? A factory. So maybe a class is a factory? It's a blueprint. So we've got two things, factory or blueprint. Okay? Now, what's a static method?
Something that would apply to every car.
Something that applies to every car, but an instance method also applies to every car.
Like a series.
Sorry?
Like the number of cars that have been made.
Beautiful. Okay? Like the number of cars that have been made. It is an operation invoked on the factory. That's why it's not a blueprint. Blueprint, you don't put operations, you invoke operations on. There's no state associated with it. It can't change. A factory is something that's an object. It's like an object. It keeps some state. And you can start assembly, you can stop assembly, you can figure out how many cars were made. That's your static methods. Okay? Manufactured by is like an instance of operation. Okay, you can have multiple cars manufactured by a factory. You can instantiate a class multiple times. You can accelerate, and you can start assembly and find the number of cars made. You can have state like that. Class, instance of, get factorials, and you can have also you know, a looping factorial method in a class, which is a static method. Okay? Questions? So class method is invoked on the class, instance method is invoked on the class instance. Okay? Since class can be active with state and so forth, it's more like a factory than a blueprint. Okay? If you come from C++, they often use the word blueprint there, even though there are static methods there too. But in Smalltalk, they didn't call these static methods, they called them class methods, which is what I will do also, because they're invoked on the class. The fact that they're static is just an implementation thing. Okay? Now, there's something called the factory pattern, which I may or may not cover in this class. And whenever I use a factory analogy, you know, some of my colleagues and students say, you're confusing them. You know, there's a factory pattern too. So please don't get confused. We all the time use words that are overloaded, that have more than one meaning. So it's, okay. Okay. So just as I can have static properties, I can have non-static properties or instance properties, but I just remove the word static from all my definitions. So these are number and factorial static properties right now, and they become instance properties. So no real concept needed in terms of properties, it's just which methods we are dealing with. Okay? You know the definition for non-static properties. I get rid of the word static. So this just as we have static keyword here in the method. We don't. Okay. Let's talk about the rules about static and non-static. And I'm not going to talk about them in great depth. I'll in the end reference you to some material where I deal with static much more in depth. When I actually teach 110, you know, we start with public static void main, right? And I don't just say this is magic. I really go deep into static there. So I just don't want to cover this here now. And I'll give you enough that you'll be able to, you know, deal with this, understand enough for this course. So this is a static global variable. It's a global variable because it's accessible to multiple methods. It's declared outside methods and inside the class. Okay? And so this is a global variable. It's declared outside a method. Okay? So it's created in memory without creating an object. As soon as the class is referenced, as soon as somebody goes and instantiates the class or invokes a method in the class, Java will load the class and allocate the memory. So no object need be allocated at that time, instance B. Okay? So for those of you who know it, what are the rules between static and non-static? Let me first get it from you before I give them to you. Can an instance method access the static variable? Yes, because from my card, should I be able to see how many cars were produced on my dashboard? I mean, I don't know if it's good user operation or not, but is that possible to do? Because that exists. From a factory, does it make sense to go and say accelerate? Accelerate on what? Nobody might have bought your car for all you know. Or there may be thousands and millions of cars. Which car should you accelerate? So from my start assembly operation, I shouldn't be able to go and say accelerate. Accelerate what? Okay. So now, should an instance method be able to access static variable? It exists. Should an instance method be able to call a static variable method? Yes, it exists. The factory is always there, but not vice versa. A static method cannot call an instance method. Accelerate on what? A static variable method cannot access the number of miles run, put on what car. Okay. So this is a local variable. That's a global variable. Static methods can access only static global variables as they are invoked on classes which would not know which instance variable should be accessed or which instance method on what object an instance method should be involved. set number, and I go and say, I have now a global variable, no static, but it's less global than a static variable. Why? A variable is global if it can be accessed by multiple methods. It's less global than a static variable because it can only be accessed by instance methods and not static methods in that class. Both methods are defined in the class, but it can be accessed only by instance methods and not static methods. So it's less global. Okay? Questions? So it's created as part of a specific object. Okay, and when set number is called, there is some object on which it has been called. So set number will go and then access that number, that object that the method is being called. Okay, so we know that set number knows which one to access. When a static method is called on a class, it doesn't know which one to access. So that's sort of the implementation explanation of that. Okay? Questions? So instance methods are invoked on a specific instance and can access that instance's variable and also static variables of that class. Static variables are more global than instance variables as they can be accessed by both instance and static methods. Okay? Questions? Okay, so like I said, if you really want to see good examples, like the example of number of instances produced and so forth, there are a separate set of notes that I've created, and we just won't have time to go more in depth there. Okay. So I have 7 minutes left.